and they are already available on LMS. So I'm not going to teach anything new, but nonetheless, I'll record the lecture for this year also. I already started doing that. Okay, so let's talk about the next unit, which is ultrasonics. I'll first, we'll see a couple of slides here. We'll start again with the applications of ultrasonics. Ultrasonics, you already know, right? कि ultrasonics high energy sound waves होती हैं. Ultrasonic जो होती है, इसके applications है, they can be used for machining and drilling because they are high energy sound waves. There is something called as ultrasonic cleaning also. If you want something to be absolutely clean, उसको आप किसी container में dip करते हो. In that container, you either fill ethanol or acetone or water. आप pure water use करते हो, उसमें you put a few drops of ethanol or acetone, and then उसके through आप ultrasonic waves pass करते हो. And that is basically ultrasonic cleaning. Ultrasonic soldering, welding, again because of the high energy content, ultrasonic waves use करके आप weld भी कर सकते हैं, solder भी कर सकते हैं. There is a process called as emulsification. The milk packet, if you buy from the market, you might have read on the packets that the milk is homogenized, right? So what happens, milk may usually you have the liquid and you have the fat also. If you have two liquids which are immiscible, which basically means that you cannot mix the liquids, for example, if you have oil and water, oil आपका water के ऊपर float करता रहता है, but using ultrasonic waves you can mix them, and that process is called as emulsification, या जिसको आप homogenization भी बोलते हैं. And this has wide applications in industry, in paint. आपके जो पेंट आते हैं मार्केट में, वो आप जो घरों को पेंट करते हैं, डोर्स को पेंट करते हैं, all those paint. Most of the medicines, cosmetic products, dyes, shoe polish, milk, anything which involves mixing two liquids which usually do not mix with each other. Usually ultrasonic waves are used to mix those liquids here. Medical applications, pregnant ladies का ultrasound होता है usually, right? We can have X-ray also, but because X-rays are dangerous, so that is why ultrasound is preferred. Non-destructive testing is another application. For example, you have something, आपके पास में एक cube है and cube के center में एक crack है. You want to test the cube if there is any kind of, let's say, a crack in the cube without destroying the cube. Using ultrasonic waves, you can do that. आप cube के ऊपर से ultrasonic waves नीचे की तरफ भेजते हैं, crack में से आपकी ultrasonic waves पहले reflect होके आ जाएंगी as compared to the other part where there are no cracks. So without destroying any object, you can test it for any kind of cracks or any irregularity. अगर for example आपने कुछ बनाया है and उसमें if there is an air bubble or something like this, you can make all those kind of testing using ultrasonic, and the name non-destructive testing is used because you are testing it without destroying the sample.
Ma'am,
that is, Hanji.
Ma'am, then why do we use X-ray instead of this ultrasonic to, test cracks in bones and other body parts?
There is a limit up to which ultrasonic waves can travel. X-ray can, being electromagnetic waves, they can travel extremely large distances. Ultrasonic, being sound waves and mechanical waves, they cannot travel that much large distances. So that is why X-rays are also used.
Okay, ma'am.
Hanji. You already know the meaning of ultrasonic, right? Anything which is beyond our audible range. And we know that audible range for human is 20 to 20,000 hertz. Ultrasonic waves have frequency greater than 20,000 hertz, or 20 kilohertz is usually the word that is used. Another thing is that whether it is infrasonic, yeah, audible or ultrasonic, they are going to travel with the same velocity. आपकी जो velocity sound waves की, if you are saying it is 340 meter per second, you have the same velocity in air for infrasonic फॉर ऑडिबल, फॉर अल्ट्रासोनिक। तीनों की एयर में सेम वेलोसिटी रहेगी, वाटर में तीनों की सेम वेलोसिटी रहेगी. So velocity of all these three is same, but we know that velocity is product of frequency and wavelength. So ultrasonic waves have high frequency and then lower wavelength, because your product of frequency and wavelength has to remain the constant, which is velocity of the sound here. So audible rays, they are going to have higher wavelength as compared to ultrasonic waves. If you talk about the hearing range of different animals, or if you compare it with respect to humans, cats have much wider range as compared to humans, dogs, elephants, cattle, and bats. You know that most of these, and for example, even rats also, their range is much larger. And that is why in homes, many times you have the products, right? आपके पास कुछ products होते हैं, electrical, it's like mosquito repellent जैसे जो दिखते हैं, you plug them in and they will just produce ultrasonic waves. उनकी जो frequency है वो बहुत large होगी, which will be intolerable to the rodents and they will run out of the house. So those repellents, rodent repellents, are based on ultrasonic applications. If you talk about the proper, हाँ जी बच्चे.
Ma'am, do we have to learn that table or?
No, you don't have to learn. Yes.
Okay, ma'am.
That was just to show you the range, different range.
Okay,
you don't
ma'am.
have to run it. But you should know the range of ultrasonic waves, that it's 20 hertz to 20,000 hertz. That's all you need to know.
Okay, ma'am.
Okay. If you talk about the property of ultrasonic waves, they are mechanical waves, right? And hence they need a medium to travel. If there is no medium, you cannot produce you cannot make ultrasonic waves to travel from one place to another place. For example, if we humans want to talk through vacuum, we cannot do that. The same is true for ultrasonic waves also. High frequency है, hence इनकी जो energy है वो भी high होगी. High energy की वजह से आप इसको welding, soldering, etc. के लिए use कर सकते हैं. अल्ट्रासोनिक वेव्स हैं, बीइंग द वेव्स, इनका रिफ्लेक्शन होगा, इनका रिफ्रैक्शन होगा और इनका एब्जॉर्प्शन भी होगा. All the phenomena that are associated with waves are going to happen with ultrasonic waves also. Sonar, you might have heard, is because you can make ultrasonic waves travel large distances without any appreciable loss of energy. The reason being that because इनकी frequency large होती है, wavelength small होती है, and you know about the diffraction, right? Diffraction तभी होता है जब आपका जो size of the wavelength is comparable to the size of object. अगर इनका wavelength बहुत small है तो diffraction है वो negligible होगा. अगर उसका diffraction negligible होगा, they can travel the large distances. And उनका dispersion भी नहीं होता है ultrasonic waves का. High energy content है, so they produce intense heating effect also. अगर आप उसको किसी मटेरियल के थ्रू पास करोगे तो वहां पे वो इंटेंस हीटिंग इफेक्ट प्रोड्यूस करेंगे. Hence it can be used for drilling or cutting of the materials also. The last point that we discussed in the previous slide, previous slide, where we did talk about emulsification, where we said कि आप दो liquids को mix करते हो. This is the reason for that. अगर आप ultrasonic waves को किसी liquid medium के through propagate करते हैं तो क्या होगा, बीइंग लॉन्जिट्यूडनल वेव्स, आपके कंप्रेशन, रेयरफैक्शन उसमें बनते चले जाते हैं. एंड उसमें क्या होता है, बबल्स बनते हैं. बबल का साइज जैसे ही रेयरफैक्शन आएगा बड़ा होगा, कंप्रेशन आएगा छोटा होगा, बड़ा होगा छोटा होगा, बड़ा होगा छोटा होगा, एंड इवेंचुअली बबल के अंदर हाई टेम्परेचर और हाई प्रेशर बिल्डअप हो जाएगा एंड इट विल कोलैप्स. एंड दैट इज व्हाई two immiscible liquids, they will mix with each other eventually. This is the experiment that you perform in your lab also, right? ये वाला जो experiment है वो आप अपनी lab में भी करते हो. यहाँ पे what you do in your lab is कि आपके पास में यहाँ कहीं पे reflector होता है जिसको आप ऊपर नीचे move करते हो. यहाँ पे आपके पास में एक ultrasonic producer होता है. So you produce ultrasonic waves, they travel up and यहाँ से वो reflect होके वापस आ जाती हैं. Ultrasonic waves again being longitudinal waves, यहाँ पे आपके क्या होगा, compression and rarefaction के reasons यहाँ पे produce हो जाते हैं. And this is what you do in your lab also, जहाँ पे आप current maximize करते हो, and those subsequent positions जहाँ पे आपका current maximum या minimum होता है, वहाँ पे आप reading note करते हो. So you are basically measuring the distance between either two nodes or anti-nodes के बीच में आप distance measure कर रहे हो. And you determine the velocity or the, I don't know, the frequency of ultrasonic waves in that experiment probably. Velocity, as I said before, velocity आपका product होगा frequency and wavelength का. Ultrasonic waves हो या infrasonic हो या आपकी audible range में हो. For example, air में अगर उसकी velocity fix है, तो ultrasonic की we know that high frequency है, तो automatically wavelength है वो कम हो जाएगी. Infrasonic की frequency बहुत कम है, hence their wavelength is extremely large. अगर आप किसी particular medium में velocity की बात करते हैं, right? This is velocity of air, velocity of sound in air. But if you talk about velocity in any different medium, then velocity is given by this expression here: square root of e over rho या y over rho. Y या e है वो आपका modulus of elasticity है, rho है वो density of the medium है. हर एक मीडियम का मॉडुलस ऑफ इलास्टिसिटी डिफरेंट होगा, हर एक मीडियम की डेंसिटी डिफरेंट होगी. Hence, your velocity of sound, whether it's infrasonic, ultrasonic, or audible range, will be different in different mediums. So these are the property of ultrasonic waves. Now we are going to.
Ma'am, can you please explain the first point again, which is on this slide?
This one or this one?
When ultrasonic waves are propagated into a liquid bath.
Okay, so what we are saying is that, for example, you have something like this, right? यहाँ पे आपने एक रिफ्लेक्टर लगा दिया है, एंड यहाँ पे आपने एक अल्ट्रासोनिक साउंड प्रोड्यूस करने का लगा दिया. लेट्स से पीजो इलेक्ट्रिक ट्रांसड्यूसर यूजुअली यूज करते हैं. सो व्हाट वुड हैपन, इट विल प्रोड्यूस अल्ट्रासोनिक वेव्स and they will be reflected back from here to here, right? So ultrasonic waves, being again the longitudinal waves, जब वो यहाँ से यहाँ travel करेंगे, they will travel in the form of compressions and rarefactions. जब वो वापस यहाँ से यहाँ करेंगी, फिर दोबारा वो compressions और rarefactions की form में travel करेंगी. Hence आपके क्या होंगे, nodes और anti nodes यहाँ पे बनने start हो जाएंगे. Nodes पे आपकी high density होगी. अब इस केस में क्या होगा, अगर आपने फॉर एग्जांपल इसमें एक लिक्विड फिल किया था, अब लिक्विड की जो डेंसिटी है वो कांस्टेंट नहीं रहेगी. आपके जो रीजन ऑफ कंप्रेशन है वहां पे लिक्विड की डेंसिटी ज्यादा हो जाएगी, जहां पे आपके रीजन ऑफ रेयरफेक्शन है वहां पे आपकी लिक्विड की डेंसिटी है वो कम हो जाएगी. आप जब लैब में एक्सपेरिमेंट करते हो, आप जब नोब को ऊपर घुमाते हो, आई डोंट नो इफ यू हैव डन दिस एक्सपेरिमेंट और नॉट, यूजुअली यहाँ पे देयर इज अ नोब हियर. When you rotate this knob, basically you are changing the distance between this reflector and this ultrasonic producer here. आप इनके बीच में distance change करते चले जाते हो, and there is an emitter connected to the circuit, and then you make the observations. You notice on this knob the reading whenever the emitter current is minimum or maximum. अगर let's say यहाँ पे वो maximum होगा आपका current, तो next वो यहाँ पे maximum होगा. And you know what is the difference between nodes and antinodes. Using that, you can calculate the wavelength, and then you can calculate the velocity or the frequency of the ultrasonic waves in that particular medium. So
Okay,
this is meant by the above point. Now we are going to talk about something, production of ultrasonic waves. Let me open a blank screen now.
मैम,
हाँ जी.
मैम रीजन ऑफ कंप्रेशन पे डेंसिटी इंक्रीज होगी कि डिक्रीज होगी?
कंप्रेशन पे आपकी डेंसिटी इंक्रीज हो जाएगी.
ओके मैम.
हाँ जी. So ultrasonic waves, how can we produce them? There are two ways for the production of ultrasonic waves. One is piezoelectric transducer or piezoelectric oscillator. The second one is magnetostriction oscillator. We'll talk about each one of them independently, a bit in detail. Piezoelectric oscillator is basically based on piezoelectric effect. And what is piezoelectric effect is, it is something which is very interesting. And this is the reason, and this effect is also used in your lighters, cigarette lighters or gas lighters. And this is also used, if you have seen, we discussed that in the very first lecture also, but if you have looked at the shoes of the small kids, usually whenever they walk, there is a light produced continuously, blinking light there. It is based on the piezoelectric effect. So usually what happens is that there are certain crystals, and this effect is not observable on all crystals. There are specific crystals only. 2 slides back. You want to see the slides? Just give me a second. This one?
Ma'am,
Ma'am, slides are
screen share is
not.
off.
Yes,
Slides are
ma'am.
not visible.
Slides are not visible.
Yes, ma'am.
Okay. Is it visible now?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay.
ma'am.
Someone was asking for this slide, right? Okay, done. Okay, so talking about the piezoelectric effect, this effect is observed only in specific crystals. So there are certain crystals, again, such as quartz, tourmaline, or Rochelle's salt. And these crystals are example of naturally occurring crystals. There are a lot of man-made crystals also which show the piezoelectric effect, but these are all naturally occurring crystals. So what is special about these crystals is that if, for example, you have a crystal of this material and imagine it in 3D here. So now if you apply a pressure on this crystal, let's say आपने इसको pressure apply करके इसको compress कर दिया है. अगर आप इसको compress करेंगे, its dimension will change in probably this way, right? So what would happen that not only the dimensions will change, इसके opposite faces पे opposite charges भी appear हो जाएंगे. And the reverse is also true. Sorry, it's not exactly the reverse. The opposite of this scenario is also true, which basically means that if you have this crystal and rather than compressing it, if you expand it, अगर आप इसको stretch कर देते हैं, again opposite charges will appear, but अब जो opposite charges होंगे उनकी polarity भी opposite होगी. अगर first time इस साइड पे पॉजिटिव आया था और इस साइड पे नेगेटिव आया था, तो अब यहाँ पे नेगेटिव आएगा और यहाँ पे पॉजिटिव आएगा. Why does this happen? To explain it briefly, for example, quartz is nothing but it's a silicon oxide. Silicon has slightly positive charge. Oxygen has slightly negative charge. तो जब कभी भी आप इसको कंप्रेस या एक्सपेंड करते हो, व्हाट यू डू इज दैट यू फोर्स सिलिकॉन एंड ऑक्सीजन टू अलाइन इन सच अ वे दैट कि सारे के सारे जो ऑक्सीजन लोअर लेयर में होते हैं वो नीचे की तरफ आ जाएंगे और सारे के सारे जो सिलिकॉन है जिनके ऊपर स्लाइटली पॉजिटिव चार्ज है वो आपके ऊपर की तरफ आ जाएंगे. So what would happen? You will have plus here. You will have यहाँ पे आपके सबके सब सिलिकॉन अलाइन हो जाएंगे, यहाँ पे आपके ऑक्सीजन अलाइन हो जाएंगे, फिर यहाँ पे आपके सिलिकॉन अलाइन हो जाएंगे, सारे के सारे ऑक्सीजन अलाइन हो जाएंगे एंड सो ऑन. इवेंचुअली बॉटम पे आपके ऑक्सीजन सब आ जाएंगे, ऊपर सिलिकॉन आ जाएंगे, अंदर पॉजिटिव नेगेटिव जो है वो कैंसिल होता चला जाएगा एंड सरफेसेस पे एक साइड में आपको पॉजिटिव मिल जाएगा, एक साइड में आपको नेगेटिव मिल जाएगा. किस साइड पॉजिटिव नेगेटिव मिलेगा दैट वुड डिपेंड ऑन द क्रिस्टल. And if the positive or negative is going to happen on these surfaces or ये side वाले surfaces पे होगा, that will also happen on the crystal. That will also depend on the crystal to crystal. But the main takeaway point from here is that these crystals have certain properties which are in such a way that अगर आप इन crystals को compress करते हो तो आप एक potential difference generate कर देते हो. अगर कंप्रेस करके आपने पोटेंशियल डिफरेंस जनरेट किया है वो इस वे में किया है कि यहाँ पे आपका पॉजिटिव आया है और यहाँ पे आपका नेगेटिव आया है, तो अगर आप इसको एक्सपेंड करोगे तो आपकी पोलैरिटी है वो भी ऑटोमेटिकली चेंज हो जाएगी. दिस इज बेसिकली कॉल्ड एज piezoelectric effect or many times direct piezoelectric effect. Its inverse is also true. इनवर्स में अब आप क्या करोगे? इन इनवर्स अभी डायरेक्ट में आपने प्रेशर अप्लाई किया, पोटेंशियल डिफरेंस जनरेट किया. इनवर्स क्या होगा? आप पोटेंशियल डिफरेंस अप्लाई करो और कंप्रेशन या एक्सपेंशन आप जनरेट कर दो. दैट वुड बी इनवर्स ऑफ इट, राइट? लेट मी रिपीट दैट. If direct piezoelectric says that you apply the pressure and generate a potential difference. If I want to talk about inverse or reverse of it, that would be you apply a potential difference and you generate the change in dimension. And that change in dimension could be compression or it could be rarefaction also. It could be any of the things. So now what would happen? Suppose you have a crystals, आपने इसको किसी इलेक्ट्रिक फील्ड में रख दिया है. There would be an automatic change in the dimensions here. Now, if you change the direction of electric field, अगर आप डायरेक्शन इलेक्ट्रिक फील्ड की अब चेंज कर देते हो, तो अगर पहले आपका क्रिस्टल इस पर्टिकुलर डायरेक्शन में एक्सपेंड हुआ है तो अब वो इस डायरेक्शन में कंप्रेस हो जाएगा. It would depend on the direction of electric field. Anyone has any doubt on the direct or inverse piezoelectric effect?
मैं एक बार इनवर्स वाला फिर से एक्सप्लेन कर दो.
हाँ जी बच्चे. So in the direct piezoelectric effect, we said you apply the pressure, you generate the potential difference. We are saying its inverse is also true. आप क्या करो? आप potential difference apply करो and you can generate compression or expansion in the crystal. आप potential difference apply करने का क्या मतलब होगा कि यहाँ पे आप इस crystal को let's say आपने एक battery से connect कर दिया and that battery is in such a way that. So what would happen here? You are applying positive charges here and negative charges here. So this will be your direction of electric field. So what would happen to this crystal? इसकी जो dimensions हैं, they will change. Now, if you change the polarity of the battery, in such a way that now you are applying positive potential on this surface and negative potential on this surface, so that this is your direction of electric field. तो पहले अगर इस axis के along, if you talk about this particular axis here, अगर ये expand हुआ था, तो जैसे ही आप direction of electric field change करोगे, तो अब ये compress हो जाएगा इस particular direction में. This is inverse piezoelectric effect. Now, what I can do is that rather than connecting a DC battery here, if you can connect an AC battery here. तो क्या होगा? आपका इलेक्ट्रिक फील्ड AC की जो फ्रीक्वेंसी होगी, उस फ्रीक्वेंसी के साथ इस क्रिस्टल के ऊपर आप जो इलेक्ट्रिक फील्ड अप्लाई करोगे, उसकी जो डायरेक्शन है वो चेंज होती चली जाएगी. एक बार इलेक्ट्रिक फील्ड इस डायरेक्शन में लगेगा, फिर इस डायरेक्शन में लगेगा, एंड it will be a repetitive cycle. So what would happen to this crystal? एक बार ये expand करेगा, एक बार shrink करेगा, expand करेगा, shrink करेगा, expand करेगा, shrink करेगा continuously. Now, if I can make this frequency in the ultrasonic range, so this crystal will start changing its dimension with ultrasonic frequency. अगर ये जो आप यहाँ पे ऑल्टरनेटिंग पोटेंशियल जो अप्लाई कर रहे हो, अगर इस ऑल्टरनेटिंग पोटेंशियल की जो फ्रीक्वेंसी है, we'll talk about how we can do that also. If I can somehow manage to get the frequency of this alternating electric field that you are going to apply on this crystal in the ultrasonic range, so this crystal will start vibrating with ultrasonic frequency range. अगर ये क्रिस्टल अल्ट्रासोनिक फ्रीक्वेंसी रेंज के साथ वाइब्रेट करेगा तो इसके आसपास में जो एयर होगी वो भी उसी फ्रीक्वेंसी के साथ में वाइब्रेट करना स्टार्ट कर देगी, and you can generate ultrasonic waves using this principle. So in the piezoelectric oscillator, the production of ultrasonic waves is based on the inverse piezoelectric effect, not the direct piezoelectric effect. So production of ultrasonic waves is based on this principle. Now, every crystal, in the beginning of waves and oscillations, we said that every single object has a natural frequency, right? Similar is the case with this crystal also, whether it's quartz crystal, which is usually used for piezoelectric transducer. The frequency of this crystal, the natural frequency, this frequency is the natural frequency, is given by this expression here, where L is the length or the thickness of the crystal, E is the modulus of elasticity of the crystal, rho is the density of the crystal. This is the natural frequency. Now we know in the resonance, resonance कब होगा जब इस क्रिस्टल की नेचुरल फ्रीक्वेंसी और ये जब आप ऑल्टरनेटिंग पोटेंशियल जो अप्लाई कर रहे हैं इनकी फ्रीक्वेंसी आपस में मैच कर जाएगी, then resonance will happen in that case. रेजोनेंस होगा तो आपका एम्पलीट्यूड है वो लार्ज हो जाएगा, and
Excuse me,
that
ma'am.
required in this case.
Excuse me, ma'am.
हाँ जी.
Ma'am, please explain this natural frequency again.
Okay. Every single object, including us humans, have a natural frequency. For the case of piezoelectric crystals, this natural frequency is given by this expression over here, where usually it's 1/2L or 1/2T. It could be either thickness or the length of the crystal. E is the modulus of the elasticity of crystal. Rho is the density of the crystal. Now, ये अगर जो natural frequency crystal की है, if you match this frequency with the frequency of the alternating field that you will be applying on this crystal, resonance will happen in that case. I'm saying the frequency of electric field that you are going to apply on this crystal becomes equal to the natural frequency of the crystal. Resonance will happen when this condition is met. You will have resonance established. Remember in the force oscillation we did talk about resonance. आप जो external force apply कर रहे हो उसकी frequency अगर natural frequency से match कर जाती है, then you say that resonance is established in that case. Now all we have to do for the piezoelectric oscillator is figure out how to produce an alternating electric field whose frequency is in the ultrasonic range. हमारे घरों में जो इलेक्ट्रिसिटी आती है that is 50 hertz. We have to make that 50 hertz frequency into a frequency greater than 20 kilohertz. How can we do that? Anyone has any idea about that?
Ma'am,
Resonance करो.
Amplifier.
Amplifier use कर सकते हैं. Anything else that we can do
ma'am,
from whatever we have studied so far? अभी तक हमने जो waves and oscillations में पढ़ा था, is there something from that we can pick up to generate the frequency in the ultrasonic range?
Clamper,
हाँ जी बच्चे.
clamper.
हम लोगों ने क्लैंपर नहीं पढ़ा. हाउ अबाउट एन एलसी सर्किट? एलसी सर्किट की क्या फ्रीक्वेंसी होती है? एलसी सर्किट हम लोगों ने पढ़ा था ना.
1/2 pi
1/2 under root LC.
राइट. ये आपकी फ्रीक्वेंसी होगी. एलसी सर्किट में जो करंट होगा और वोल्टेज जो है, दोनों के दोनों इस फ्रीक्वेंसी के साथ में ऑसिलेट करेंगे. राइट. नाउ इंडक्टर की वैल्यू चूज करना इज अंडर आवर कंट्रोल. कैपेसिटर की वैल्यू भी चूज करना हमारे कंट्रोल में है. We can choose the value of inductor and capacitor in such a way that यहाँ पे ये जो फ्रीक्वेंसी है जिसके साथ आपका करंट और वोल्टेज ऑसिलेट कर रहे है, this comes in the ultrasonic range. We can do that. So यहाँ पे जब हम कह रहे थे that we need to apply an alternating voltage, और वो alternating voltage जो है वो ultrasonic range में होनी चाहिए. We can do that by using an LC circuit. We'll discuss that in the next class. I think my time is up. हाँ जी बच्चे.
Ma'am,
हाँ जी.
in the last slide, ma'am, can you tell how we will take L? That is, we will take horizontal distance or vertical distance?
It would depend from the crystal to crystal.
Ma'am, like here we have applied potential difference across vertical. So shouldn't L be taken across vertical? Or like,
Yes, in this particular case, if it would depend in which direction you are producing your ultrasonic waves.
okay, ma'am.
अगर आपकी ultrasonic waves जो हैं, for this particular case you are correct, because मैं इस direction में dimensions change कर रही हूँ in this particular case. So I should ideally take L in this direction for this particular case. But अगर ऐसा होता कि ये potential apply करने के बाद में अगर मेरा जो crystal है वो इस direction में change होने की बजाय अगर ऐसा हो जाता, right? फिर उस केस में I should have taken L in this direction. It depends कि आपकी अल्ट्रासोनिक वेव्स जो प्रोड्यूस हो रही हैं वो इस डायरेक्शन में प्रोड्यूस हो रही हैं या इस डायरेक्शन में प्रोड्यूस हो रही हैं. Depending on that, you will take your L or T.
Okay, ma'am.
हाँ जी बच्चे. Okay, we'll start from here. Last lecture में किसी एक बच्चे को डाउट था in the measurement of absorption
Yes,
coefficient.
ma'am. Yes, ma'am.
हाँ जी बच्चे. वहां पे आपने कहा था ना हम टू सोर्सेज क्यों यूज करते हैं जहां पे
Yes, ma'am.
पावर का था. द रीजन इज दैट इफ देयर इज एन ऑफसेट, लेट्स से आपके जो चैम्बर में है उसके रेवर्बरेशन टाइम में कुछ ऑफसेट है.
Ma'am, what do you mean by offset?
लेट्स से देयर इज सम एरर इन इट.
Okay, ma'am.
तो वो एरर अगर आप सिंपल एक बार में कैलकुलेट करेंगे तो वो एरर जो है वो एज इट इज एब्जॉर्प्शन कोफिशिएंट में ट्रांसमिट हो जाएगी.
Okay,
बट
ma'am.
अगर आप दो बार उसको करेंगे और दोनों को आप सब्ट्रैक्ट कर रहे हैं एक दूसरे से तो वो कैंसल आउट हो जाएगी.
Okay, ma'am.
That is why we use it. एरर या ऑफसेट का मतलब ऑफसेट इज द राइट टर्म. लेट्स से कि आप ऑफसेट इज सिंपली अगर जीरो यहां होना चाहिए बट आपका एक्सपेरिमेंटल सेटअप कुछ ऐसा है कि जहां पे 1 है वो वहां पे 0 को रीड कर रहा है, उसको हम ऑफसेट बोलते हैं.
Okay, ma'am.
सो वो ऑफसेट कैंसल आउट करने के लिए यूज किया जाता है.
Okay, ma'am.
ओके, स्टॉप. We'll see you in the next class. Saturday आप लोगों की एक्स्ट्रा क्लास होएगी 12:10 to 1. I'll tell you the Zoom link for the same in the next class.